So this is an exam question looking at spirometer traces. I've got a couple for us to look at. And the question here is, exercise has an effect on oxygen consumption, efficiency of ventilation and risk of type 2 diabetes. Fair enough. Spirometer can be used to study oxygen consumption, which we know because we've looked at the structure of how a spirometer works. We've already looked at how to calculate using these traces. Spirometer trace shown was obtained for a 90 kilomole at rest. Calculate the mean rate of oxygen consumption at rest for this person. It's centimetres cubed, kilograms per kilogram per minute. Now, these are things to keep in mind here. Here it's centimetres cubed. That's the unit they want it in, but they're giving you in decas here, so you're going to have to change. And here they want it via minutes, but they're telling you in terms of seconds. So the first thing you do is work out kind of what is represented by a minute on the graph. So each one of these, that's 10, 20, 30, 40, 50, 60, that's a minute. So from there to there is a minute, okay? And then you want to work out the volume, the change in the volume of oxygen consumed basically using the ventilator, using the spirometer, sorry, not ventilator, spirometer. So you put your lines on. So you put a line at the top, going down to where you finish, and a line where you finish going straight along the bottom there, so you work out the difference there, which is roughly half a decameter, because two of those big cubes, not roughly is, two of those big squares is one, so half of that is half a decameter cubed. Now that's a decameter, so you need to convert it into centimetres, so that becomes 500 centimetre cubed, okay? And it's 500 per minute, so we've done that bit, and we've done that bit. Okay, because we've done it for a minute, done all that for the minute, and we've done the volume there. Okay, so we know that's there. So we've done those two bits. And then it's per kilo. So all you have to do is 500. So you do 5, oh, can I do this? 500, ooh. And then you divide it by 90. And that will give you, per centimetre cubed per kilogram per minute. And the answer to that is 5.5. So the answer to this one here is 5.5. Okay, that's how you work it out. Let's look at another one. Oh, and there's a mark scheme there. So you won't see it's worth 3 marks. If you just put the answer down, you get 3 marks. But again, I would never, ever, ever advise that, because if you make a mistake, you won't get any marks. If you do a correct conversion, millilitres to decas, even if you do it wrong, you're going to get a mark for that. So do that. And here you're getting a mark for the body weight, so dividing it by 90 there, and then you're getting your 1 mark there for working it out. Okay. Now here's another question. I'll get rid of that. Spirometer filled with oxygen was used to record the breathing of a student. The student was sitting at rest and was instructed to breathe normally. Spirometer trace is shown. We can see spirometer trace there, and we can see breathing. And it starts to get bigger and spikier. A question. Place a cross in the box next to a correct description of changes shown in the spirometer trace. What is the spirometer trace showing you? The lines are getting bigger. Okay, so that means they're breathing deeper and they're getting closer together. Look at them, they're quite spread out there, and as you go on, they get closer and closer and closer together. So that means you're breathing faster and you're breathing deeper. So the breathing becomes faster and deeper. That's the answer to that one, A. Now, bear in mind, from this trace, you can also work out breathing rate and tidal volume and oxygen consumption. So that's what we'll do now, okay? I wonder how you get rid of that little bit there. I don't know. Apologies for that. I don't know why that's there. I don't know how to get rid of it. First question, what is the mean breathing rate for the first 2 minutes of this spirometer trace? Well, first things first, you've got to work out your 2 minutes. So 60 plus 60 is 120. There we go. And then you literally just count the number of peaks, the number of times they've breathed in. You literally count the peaks. So it's literally going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 breaths in 2 minutes. So breathing rate is 18 divided by 2, which is 9 breaths per minute. That's how you work out breathing rate using that trace. Okay. Next one. Again, sorry for that line. What is the mean tidal volume during the first minute of this spirometer trace? So here we go. First minute, 60 seconds. So we're looking at this bit here. Now, you're looking at mean. So you want to kind of put your 2 lines where you hit most of your peaks, which is what I feel I've done with my 2 lines there. I've hit most of my bottoms and most of my tops, more or less. And you work out the difference. The difference is half a decameter there. That's the answer to that one. And obviously these graphs are sometimes tricky to read, so they will give you a bit of leeway in them. That's half a decameter there. And then the last thing we're going to do is looking at the mean rate of oxygen consumption by the student for this whole spirometer trace. Now the trace is 6 minutes, 360 seconds, 6 minutes. 36 divided by 66. So you're doing a spirometer trace. So you draw a line from the top to the bottom and a line from the bottom straight across, and then that is your difference. So there's my lines, starting there, bringing it all the way down, hitting as best I can. I maybe could have lifted it up a bit, I don't know. And then we're going across to the bottom. That's where we end. So we're drawing a line straight across there. So we're looking at the difference from here to here. Well, 4 take away 1 is 3. So there's a volume there of 3 decameters. Okay, that's the oxygen consumed, 3 decameters there. In the time taken. So what you need to do is that's 3 divided by 6 to get it per minute. So that's because it was 3 decameters for the whole 6 minutes. So per minute, 3 divided by 6, or 3 divided by 6 equals 0.5. 0.5, and that's 0.5 decameters per minute. Okay, because that's how you worked it out. And that's that.